Hi, I am Nellen Grace Levita. I am a science teacher from the Philippines. Okay, so today I'll be discussing about the three laws of motion. Without further ado, let's start it. Have you wondered that everything on this planet is constantly moving, just like a fish jumping out of the water, a flight of a bird, or the orbit that surrounds the satellites? It is because of the force that affects the motion of the object and the systems. Yes, because of the force, we can move freely and we can move the object easily. If you are still not convinced, let's talk about the Newton's law. Okay, before we go further in our discussion, let me first introduce a little background how these laws become famous in the classical period, or even today, we still recognize this law of motion. Okay, so it was Sir Isaac Newton, an English scientist and mathematician who became famous for his discovery about the law of gravity and the law of motion. So today, this law became known as the Newton's law of motion. Newton's law of motion, it described the relationship between the motion of an object and the forces that acted on it. Okay, now in Newton's law of motion, we must to consider that the law of motion has three types. One, an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Two, force equals mass times the acceleration. And three, for every action, there is an equal opposite reaction. Okay, in the first, Newton's first law states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless it acted by an unbalanced force. So what does it mean? And what does unbalanced force mean? All right. Take a look at the picture or example, a table and a book. So when we apply physics here, as you notice that the table pushes upward on the book and the gravity pulls downward on the book. So the forces on the book are balanced. So when the forces are balanced, it means to say the object is not moving. All right. So how about this unbalanced force? What do we mean by that? Okay, just remember, if the forces on an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. However, if they are not equal and opposite, then the forces are unbalanced and the motion of the object is changing. All right. Okay, now you know what is unbalanced. when you have two objects that is not equal and not opposite. So the force it acquires is unbalanced. So the motion of the object is changing. So there is a changing of position. Right. So that's the unbalanced force means. Okay, let's have an example from real life. Look at the picture of a ball. A soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its position. Now, look, the ball or the soccer ball here is at rest. So in order for us to move this, it need a unbalanced force. So we have to kick the ball so that the ball will move. So the applied force here is unbalanced. Okay, now look at the second picture. It is a play or known as a tug of war. Okay, the two teams are playing a tug of war. So both teams are exerting equal forces on the rope in an opposite direction. So this balanced force result in no change of motion. Okay, so the forces that apply in this play is balance force, no change in position. How about the law of inertia? Did you know that law of inertia is also in the Newton's first law? When we say law of inertia, inertia is the tendency of an object to resist changes in its state of motion. In the first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to change its position. Just like here, look at the example. A power locomotive begins to pull a long line of boxcars that were sitting at a rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a larger force to change their position. Once they are moving, it takes a large force to stop them. So, means to say, or in short, if you have a large mass object and you tend to move that large mass object, you have also a large force needed in order to move that large object. Just like this one. Okay. Next is, now look at the picture number 2. On your way to school, a bag flies into your windshield. Since the bag is so small, it has a very little inertia and exerts a very small force on your car. It's so small that you don't even feel it. Okay, so mean to say that for the object that has a little amount of inertia, it also needs a little amount of force to apply it so that that object can move. Okay, now, if objects in motion tend to stay in motion, why don't moving object keeps moving forever? Okay, remember that things don't keep moving forever because there's almost always an unbalanced force acting upon it. Okay, so every object that you tend to put here at rest, the object at rest, you will not say it will not move forever, because there is, we call an unbalanced force. When that unbalanced force acted on that object will tend to move. Okay? Yes. Just like, for example, a book sliding across a table slows down and stops because of the force of friction. If you throw a ball upward, it will eventually slow down and fall because of the gravity. How about in the Newton's second law? It says that force is equals to the mass times the acceleration. And what do we mean by acceleration? Acceleration, it is a measurement of how quickly an object is changing its speed. So what does the formula F equals to ma means? Or force is equals to mass times the acceleration. Okay, so force is directly proportional to its mass and the acceleration. Imagine a ball of a certain mass moving at a certain acceleration, so this ball has a certain force. How about if you want to twice your ball? So twice as big. So the mass itself is doubled, but the acceleration is at constant. So the force equals to mass times acceleration says that this new ball has twice the force of the old ball. Okay, let's talk about more about the force equals to mass times acceleration. Basically, this formula means that the force of an object comes from its mass and its acceleration. Just take a look at this formula. Okay, what if you double the mass and the acceleration? So we have the mass is doubled, the acceleration also doubled. So we got a force of quadruples. Okay, so if you double the mass, you double the force too. If you double the acceleration, the force also doubled. So what if we decrease the mass by half? How much force would the object have now? Can you think? Doing the formula. Okay. If the mass is half compared to the original and the acceleration is the same, which say 2, the amount is 2, so the resulted force will be half. Remember that force is directly proportional to the mass times the acceleration. All right, now let's talk about the Newton's third law. It states that for every action, there is an equal and opposite reaction. What does this mean? Okay, for every force acting on the object, there is an equal force that acting on the opposite direction. Just observe on the chair, or just imagine you are sitting and right now you think that the gravity is pulling you downward in your seat. But in the Newton's third law says that your seat is pushing up you against you with the equal force. This is why you are not moving. So the balance force is acting on you while the gravity is pulling you downward and your seat pushing you up. All right. So think about it. What happens if you're standing on a skateboard or a slippery floor and push against a wall? You slide it in the opposite direction, away from the wall, because you push on the wall, but the wall pushes you back on you with equal and opposite wall. And how about if you kick something just like a rock and you push or you kick it very hard, and when you stab your toe exert a force on a rock. The rock also exert equal force back on your toe. The harder you hit your toe against the rock, the more force the rock exert back to your toe. So you got more hurt. Your toe got more hurt. Okay, so remember, in every action, there is an equal reaction. Okay, let's have a quick review. So Newton's first law states that an object in motion tends to stay in motion. An object at rest tends to stay at rest, unless it acted upon by an balanced force. For the Newton's second law states that force is equals to mass times to the acceleration. For the Newton's third law states that for every action, there is an equal and opposite reaction. All right, for additions of vocabulary, we have inertia. So inertia, it is the tendency of an object to resist changes in its state of motion. So acceleration, it is a change in velocity, or it's a measurement how quickly the object is changing the speed, the direction, or both. For the velocity, it is the rate of change of a positions along a straight line with respect to time. And force, it is the strength of or energy. So let's have to take this quick quiz. Okay. An object at rest will blank if no outside forces are applied. A, stay at rest. B, increase in velocity. C, decreases the mass. For number 2, according to Newton's first law of motion, a moving object that is not acted by an unbalanced force will A, remain in motion, B, eventually come to stop, or C, accelerate. And question number 3, a sled sliding on a flat, icy surface with a constant velocity is best described by A, Newton's first law of motion for object at rest. B, Newton's first law of motion for object in motion. Or C, Newton's second law of motion. For number 4, how does Newton's third law explain how a rocket takes off? A, the rocket's acceleration is positive while the gas's acceleration is negative, but the direction is the same. B, the rocket is at rest until ignition. Or C, the hot gases move in one direction while the rocket moves in the opposite direction but with equal force. Number 5, Acceleration is caused by a force acting on a mass. A. Newton's first law of motion. B. Newton's second law of motion. Or C. Newton's third law of motion. Now, let's check your answer. Okay, for number 1, question is, an object at rest will blank if no outside forces are applied. So the answer must be stay at rest. Number 2, according to Newton's first law of motion, a moving object that is not acted on by an unbalanced force will A. Remain in motion. Question number 3. A sled sliding on a flat, icy surface with a constant velocity is best described by B. Newton's first law of motion for object in motion. Question number 4. How does Newton's third law explain how a rocket takes off? It's C. The hot gases move in one direction while the rocket moves in the opposite direction but with equal force. Question number 5. Acceleration is caused by a force acting on a mass. The answer is B, Newton's second law of motion. So that's it for today's lessons about the Newton's law of motion. I hope you learn a lot by this. Good. That's it for today, and thank you for the listening. Goodbye.